So far, we have looked at ionic compounds as single entities. Ionic compounds actually exist as large 3D structures known as a giant ionic lattices. In this lesson, we will learn about, and you got it, these giant ionic lattice structures. When we talk about sodium chloride, there aren't actually any individual sodium chloride molecules. Instead, the sodium and chloride ions are arranged in a regular repeating 3D pattern known as a giant ionic lattice. Let's now have a look at the giant ionic lattice of sodium chloride. We know that sodium and chloride ions are electrostatically attracted to one another. Because of this, you will see that the ions are arranged so that the sodium ions are always next to the chloride ions. This arrangement is seen in all directions of the 3D structure. The electrostatic attractions in a lattice structure are very strong. Let's think about it. Each sodium ion is held in place by the electrostatic attraction of 6 neighboring chloride ions in all possible 3D directions. And similarly, each chloride ion is held in place by the electrostatic attraction of 6 sodium ions, also in all possible 3D directions. Since this lattice structure is so strong, it explains some key properties of ionic compounds. Ionic compounds have very high melting points. This is because a lot of energy is required to overcome the strong electrostatic attractions holding the 3D lattice structure in place. Ionic compounds are also very brittle. This means that they break rather easily into small pieces. A ceramic flower vase is also brittle. If knocked over, chances are it will break into small pieces. But why are ionic compounds brittle? When a force is applied to the 3D lattice structure, it will disrupt the regular repeating pattern of sodium and chloride ions. So the sodium ions are forced to be next to other sodium ions, and the same is seen with chloride ions. Like charges repel one another, and this repulsion essentially breaks the lattice structure. In summary, ionic compounds exist as giant ionic lattices, not as single molecules. The giant ionic lattice is a regular repeating 3D pattern of alternating positive and negative ions. The electrostatic attractions holding the structure intact are very strong, and this accounts for the fact that ionic compounds have very high melting points and are brittle.